Hello, and welcome. What we're going to do is a little bit on our next topic, which is called the greatest common factor, or GCF. Now, we're trying to play with polynomials still. So poly, remember, is many, and monomials is like many terms that are maybe combined a little bit. And so what we're trying to accomplish here in this segment is trying to come up or have a polynomial of a polynomial and try to find what we call the greatest common factor. Now, a definition that you need to remember is, what is a factor? A factor is a number or letter that can be taken out of the whole polynomial. So not just one part of the polynomial, the whole thing. So we can't just take one thing out. We have to make sure everything is what we need to take out, if that makes sense. If not, let's go ahead and do some of these examples and maybe things will click. So back in grade school or back in elementary school, maybe middle school, that you had to take what we call a greatest common number out. And remember, this is something that we've done before, hopefully. So let me show you an example real quick out of this. Let's say that we had 4. Let's say we had 4, the number 4. You want to find out something with that. So let's take 4 and 8. 4 and 8. Now we have to think about what numbers make 4. Well, what numbers make 4? Well, 1, of course. 1 times 2. Okay. 1 times 4. Right? Those 3 numbers multiplied are 1 times 2. Not 1 times 2. 1 times 4. 2 times 2. So 2 times that. 1 times 4 is 4. Awesome. What makes 8? 1 times 8, right? So 1, 2 times 4, and then 8 times 1. What I want you to understand is, what is the greatest number, the largest number. So what is the largest number? What is the largest number out of these two here? What is the largest number that have in common with both? And if you say 4, you are correct. So 4 is what we call the GCF, or the greatest common factor. So that's what we can take out of 4 and 8. So let's do 6. Their greatest common factor of 6 is technically, we can't do too much with that one. So we can say it's just 6, because 6 is just it. There's no other number matching it up. What's the greatest common number between 8b plus 2b? What is the greatest number that can fall into these two things that you can bring out? And here it is. So let's say I had 2 and 8. Does 2 go into 8? Yes, it does. But 8 doesn't go into 2. So we have to consider 1. 1 is always going to work. 1 times what makes it always works. So we don't really say 1. What I want to do is, does 2 is our biggest number. So we're going to say that this is 2. Is there another letter that can also come out of both of these? And if you say right here, there's a B and there's a B. How many B's can I take out of these two monomials? I can take 1 out. So the greatest common factor, or we call the GCF, is out of this 2B. Because 2 can come out of this whole thing, and B can come out because B has a similar thing. Now look at this one. This one is pretty much the same as this. However, there's no a in this one, so you can't take out an a. But can I take out a 4? Can I take out a 4? Yes, I can. So if I take out a 4, that's it. Because a 4 goes into 4, and a 4 goes into 4. So at least a 4 and a 4 can come out. Look right here. You have x times y, x squared times y plus x. What's the greatest letter and number that can come out of this? If you say x, only x, you are correct. Well, you're probably thinking, how do you know? Well, technically, how many x's do you have here? You have x times y plus x. Don't you? Don't you for that one? So you have, look right here. How many x's do you have? You have 2, right? How many x's do you have here? You have 1. Well, you can't take out 2 from 1. You got to take out 2 from 2. So that's one of the reasons why I can take one of the x's out and have them even in both. Okay? Does that make sense? Well, maybe it doesn't. Look at this one right here. 6t plus 18. 6t plus 18. What number can come out of both 6 and 18? What's the biggest number that can go into both of those? Well, 6 can go into 6. 6 can go into 18 3 times, right? So 6 can go into both. So you're going to go 6, and then you're just going to say 6 for now. Okay, so 6. What can come out of a squared plus ab? Well, there's 2 a's here, and there's an a there. So what can come out? An a, right? So just an a can come out. Well, look at this one. 6x squared minus 24x. How many x's can come out first? Well, I have 2 here. I have 1 here. So I can take out 1x. Great. Can I take out a number with that? Well, let's see. I have 6 here and 24 here. Well, let's see. 6 goes into 6 once. 6 can go into 24 4 times. Oh, so 6 can come out. So you're going to go 6x like that. So that's pretty much what you need to accomplish with this. Look at this one down here. I have 20x squared plus 44x. Well, how many x's do I have here? I have 2. How many do I have here? 1. So I can take out 1, right? And what number can go into 20 and 44? Well, 2 can. 10 can't do it. So you have to kind of look down here. So let's see, 2 can. What about 4? Can 4 go into 20? Yes. Can 4 go into 44? Yes. So I think 4 is the answer. So that's going to be 4x. Just like that. You're trying to think of the largest common number, the biggest number that go into both of the numbers. And that's what you're taking out. So what I want to do is go through some more of these, and once we take that GCF out, what would be left? Okay, so what would be left? Well, let's think about that. What would be left? So, so let's do this. 6t plus 18. We saw this one already, didn't we? And what about we do this one over here, since we already know the answer, but what's left over? So we have 6x squared minus 24x. And you know what? Why don't we do this one as well, since we're here. So let's do 20x squared plus 44x. Since we're there, I mean, we know the answer to the GCF, but what's left? So, Let's go through here. So, for example, remember looking back at our notes. What's the GCF? Well, it was 6, right? Looking back, because 6 can go into 6 once. 6 can go into 18 3 times. So it has to be 6 is your greatest common factor. So it has to be 6. Now, what is left over? And here's what I want you to do. Put a parentheses like this. Put a parentheses. What's left over? Because what you're going to do is fill in what's left over. So we took out a 6 from our equation. So you're kind of almost doing the distributive property backwards. So if we took out a 6 here, what's left? Well, we have a t, right? So we have a t. We have a plus. 6 times what makes 18? 6 times 3, right? So there you go. This is what's left over. This is what's left over. Now, what if you don't believe me? Well, here's what you could do. Do you remember when you did the distributive property and you did something like this? When you saw something like this with parentheses and you went this and this? What if you did that? Wouldn't you get back up to here? Wouldn't you get back up to there? And the answer is yes. So you're trying to do the reverse of the distributive property. And that's the whole problem of this, is that once we get to solving these, we're going to find out some solutions to them. And that's pretty much what I'm trying to get to. So let's do this one down here. This one was over here. We found it to be 6x, right? 6x. So you're going to go 6x. And then you're going to make a parenthesis because you need to know what's left over. So 6x. Well, we need what is left? What is left right here when we take out a 6x? The 6 is gone. We have one of the x's from x squared, so we just have a x left over. And we still have that minus sign. 6x, and we have 24. So 6 times what makes 24? 6 times 4. So we have a 4. Oh, we took the x out. We took the x out of here, so that doesn't exist anymore. It's right there. It's taken out. So that's your answer. This is your answer right here. That's it. That's what we call the factored form, or GCF. So this is kind of like the factored form. Sometimes is what it's called. That means it's been pretty much to its simplest terms it can go. Alright, look at the next one. Well, the next one we decided it was a 4x that was taken out of it. So we're going to go ahead and put 4x, and then you're going to find out, okay, well, what's left over? We know there's an addition in it, so put the addition back. How many 4s make 20? 4 times 5, right? Did we take out an x? Yes. How many x's do we have left? We have one x. Well, if that is true, how many 4s to get to 44? 4 times 11, right? So we have 11. Did we take out the x? Yes, we did. The x is been taken out, so that's left with this. So this is your answer here. This is your answer. What do I want to do with this answer? That's for later on videos when we get to actually solving them. And to give you a preview, we're actually going to make this equal to 0. But that's for later. That's for later. Coming up very soon, but later. Let's do a few more, and hopefully you got the idea of this. What I want to do is do kind of a long one, so you're not lost. So let's try this one. So what if I had 3x squared plus 4xy minus 3x minus 4y. So there's a big polynomial for you. What if I said, try to factor this as much as possibly can? So you're trying to find the greatest common factor that goes into 1, 2, 3, 4 terms. So I'm hoping you remember that that's 1, that's 2, that's 3. You have 1, you have addition there, you have a 1, 2, 3, 4. You have 4 terms. 4 terms. So you have to make sure that whatever number that you're pulling out goes into all 4 of those terms. So here we go. What I would like to do, I would probably say, okay, let's start with the simplicity of this. First off, I have everything pretty much all mixed up. What if I was to make this easier on me? What if I was to regroup this? What if I was to regroup this? What if I was to regroup this? What do you mean regroup this? Change things around. Change things around. So what if I said, what if I put the 3x squared here? And then what if I put the minus 3x with it? Does that make sense? That I'm just combining similar ideas or similar objects? Well, what's left over? Well, I have that 4x, y, and then I have that one. All I did is just rearrange things. And the reason I'm doing that, just to kind of say, hey, is there some commonality? So let's think about this. What if I was to take out a number in those two? What number would you take out? I would take out a 3x. Is that correct? Would I take out a 3x right there? And what is left over if I take a 3x out of this one and just this one, just for now? You would have x minus 1. Is that correct? X minus 1? Well, look at this one. What can I take out in these two? What can I take out here? I can take out a 4 and I can take out a lovely y. Well, what's left if I take out a 4 and a y from here? Well, what's left is you still have that x, you still have that 1. Well, I want you to pay close attention to this one because this is really interesting. I like these. Do you see how these and these are the same? Why don't you take those that are the same and rewrite them? So we have x minus 1. Those are the same, right? They are common, so I took that out. What else do you have left? What else do you have left? The 3x and the 4y. Put those down. So I have 3x plus 4y. There's your simplified form. This is a little bit of a struggle one. This is a challenging one. But as you grow into your math skills, you can do any of these. So let's do a couple more that are a little bit easier than this. This is kind of the overarching way of doing this. So let's do some more. And I think you got the idea. So let's try this one. 9x plus 45 and 3x to the 4th y plus 15x to the 3rd. Let's try these two. So these two are kind of, I want you to simplify or I want you to factor them. Find me the GCF. If I only wanted to find the GCF, can you do that with these two? Can you find the GCF of these two? This one? Well, isn't the answer going to be 9? Is the answer 9? 9 can go out of 9. Could 9 go to 45? 5 times, right? So 9 is the common or greatest common factor. Well, look at this two. So look at this one and this one. What number can come out of both of those? If you say 3, you're correct, because 3 goes into 3 and 3 goes into 15 5 times. So, hey, yeah, 3 is one of my answers. Well, what else can I take out? Well, let's see. I have x to the 4th, so I have 4 of those. And then over here I have 3 of them. So, how many can I take out from here and there? How many can I take out? Well, I have 4 here and 3 here. So that means I can go 1, 2, 3, 1, 2, 3. And how many are I left over? X. So how many did you take out? X to the 3rd. And there's your greatest common factor. These get harder, but I think that they're doable because you're seeing that, hey, you're getting that more advanced, so you're trying to say, hey, what can I do now to make things simpler, because very soon, like I said, we're going to start solving and finding solutions. But those are in later videos, so hopefully this helped. I'll see you on the next one.